like a Swiss watch. We're back at the San Diego Convention Center covering the 48th Design Automation Conference. I'm Brian Fuller, Editorial Director with EE Life, and with me now is my longtime colleague from UBM Electronics, Ron Wilson, who is Editor-at-large at EDN. Ron, welcome.
Thank you very much, Brian.
Good to see you as always. Ron and I sit mere meters from each other, so we see each other frequently. Okay, it's early in the day. It's, what do we got here, 11:31. It's probably a little too early to give a report card on what's going on. You and I were just talking about trying to sense what the attendance might be. It looks a little light here on Free Monday, but the day is young. Let's talk a little bit about some of the high-level themes that you're seeing, that you're interested in, that you're writing about. Let's talk a little bit about the role of embedded software and how that is migrating into the chip design process. We have a new sort of sub-theme in DEC this year for the first time about the embedded world, embedded design world. Talk a little bit about why that's important, who might be leading the charge there, and what some of the pitfalls might be.
It's sort of one of those things that's been standing in the corner being 15 feet tall and demanding feeding for several years now. But if you talk to design managers, they'll tell you that maybe 70 or 80% of the engineers that they actually employ on a chip design project aren't designing the chip, they're software developers. The reason for that has to do with integration. You know, as chips have become larger, they became systems on chip nominally. Now it's getting to the point that they're systems on chip, really. There's so much in there that the silicon developer has to provide not just the silicon, but a reference design and all the software necessary to make the silicon actually do an end product function. That's put chip developers into the systems development business. And it's brought them up face to face with two realities. One is they don't know anything about embedded software development. And two, there hasn't been any good way for embedded software development to happen until the silicon was working.
Right.
And one of the things we're starting to see, most obviously maybe with Mentor's announcement this morning, about linking their various simulation and emulation environments to their own software development environment, is companies scrambling to try and get the software development team that's sitting there burning up 70% of the engineering budget going before the chip exists, and getting them to track the chip design and to do debug as the chip is changing, so that the chip doesn't sit there and miss its market window while they're waiting for the software to finish.
So you referenced the Mentor announcement. I haven't had a chance to look at that. What's your sense of that? Is that a huge step in the right direction, a baby step in the right direction, or vaporware?
It's an important little series of steps in the right direction. Basically all it does is to provide a connection between Mentor's software development environment, which is based on the GNU tools through private release, and some of their specific chip simulation and emulation tools, like their Vista virtual prototyping tools and their Veloce hardware emulator. So the software developers can start out developing software and running it on the virtual prototype to see if it works or not. And then as blocks actually turn into RTL, they can start mixing blocks running on the virtual prototype in pure software at a high level with blocks in RTL running on the emulator at a much more detailed level. And continue this process all the way through when there's finally prototype silicon available, running the software on the prototype silicon.
Nobody does chip design from scratch anymore. It's way too expensive. We heard just moments ago from Gary Smith, who said, you know, it's costing at least $25 million. That's making venture capitalists run into places like, you know, Facebook and Groupon and stuff like that. Way too expensive. ROI, very, very sketchy. It's all about integrating IP. We've been talking about this for many, many years now. There seems to be a sense that this is serious now. Things are working. Verification is happening at the chip level, and then later at the system level. Give us your take.
Well, I think you're absolutely right. People have been assembling IP to make chips instead of starting from a clean sheet of paper for years now. The remarkable thing is that the EDA industry has almost completely ignored the fact. If you look at what design teams actually do today, they spend a lot of time looking for IP, evaluating it, fitting it together, and then attempting to verify the system without learning any more than absolutely necessary about what's really going on inside the IP. Most of the tools that they use in that process are designed for exactly the opposite flow, where they create all the IP themselves from giant files of Verilog or VHDL, synthesize it all together, and then start debugging the whole thing almost as a flat design.
Yeah.
The problem is the tools now aren't meeting the actual needs of the design teams. The design people need tools for automating the selection of IP, automating the evaluation of IP in a particular context where they're planning to use it, automating IP assembly so that they don't have to look in detail at how each pin on each IP block works and wire them together by hand and verify each connection by hand. And then having a verification flow that's driven by what the IP vendor is willing to guarantee about the IP,
Right.
rather than by everything you might learn about it by reverse engineering it.
Yeah. It's a far cry from the days of star IP, that's for sure.
Yes. And after all those years, we still don't have a generally accepted methodology for evaluating IP and saying, does this work or not?
Yeah, right. Well, Ron, I'm going to let you go in 1 second after I ask you one more question. You've been coming to DAC for many, many years, and I'm asking everybody this question. What's your secret for surviving DAC?
I think the easiest way to survive DAC is to go in recognizing you can't do it.
You can't survive?
You can't do everything. You can't write all the stories that you hear that deserve to be heard. You can't see all the people. You can't even meet all the companies you don't know about. You have to go in and look for story threads rather than factoids. There's 2 or 3 good story threads in a DAC, there's a billion factoids.
And it seems to me, and maybe this is me just bemoaning this fact, but there are far fewer startups at any given DAC than there used to be in the 90s or even in the 80s. And those are always really interesting stories.
Mm-hmm.
But maybe that's just a sign of a maturing industry.
I think it might be an illusion. I was just spending some time at a presentation that Jim Hogan and Paul McClellan gave on the business of creating an EDA startup. And one point they made is that the finances are entirely different now. For maybe the first 18 months, an EDA startup spends no money whatsoever. That even the founders don't take any salaries. And for the next couple of years, they're still very carefully minimizing their spending to try to avoid bringing in more investors than they have to. The bottom line, as Hogan puts it, is that if you can spend less than $10 million by the time you reach sustainable break-even from customer revenues, you have a chance of a bunch of people in the company becoming millionaires at an exit. If you spend more than $10 million, you're going to have to multiple rounds of funding. Not only will you not get any of the money out of it because the venture capitalists will have diluted your equity so badly, but they will have a commanding say in what the exit strategy is, and it probably will be one you don't like.
Yeah.
So there's lots and lots of startups out there, but they're all invisible at the level of DAC because none of them is going to spend 50 grand to be here.
That's interesting insight. That's a great segue because Hogan and McClellan are scheduled to join us at 1:15 today.
Oh, perfect.
So Ron Wilson, Editor-at-large from EDN, thanks as always.
Thank you.